Good morning to my YouTube channel. Today, the talk which I am going to deliver is nutrient use efficiency and integrated nutrient management. Fertilizers we apply contain different types of nutrients which plant require. The amount of nutrients present in that fertilizers we apply it varies, and the applied nutrients may not be available totally in the soil. It varies from nutrient to nutrient in the fertilizer to fertilizer. So the use efficiency it plays important role. So the depend upon the nutrient use efficiency, the all fertilizer recommendations are being done to the different crops. So whatever the fertilizer quantity we apply, whatever the nutrient available in that fertilizer, as I said, it may not be available totally. It varies from 5 to 15% depend upon the nutrient and fertilizer. So the amount of that means nitrogen output divided by nitrogen input into 100. So that gives the nutrient use efficiency. Higher the nutrient use efficiency indicates the efficient utilization of that particular nutrient, and which ultimately lead to the higher productivity of the crops and also reduced environmental impact from the fertilizer losses. So the nitrogen use efficiency plays very important role. Suppose if we increase the nutrient use efficiency, not only nitrogen, phosphorus, potash, whatever it may be, fertilizer, if we increase the nutrient use efficiency, ultimately we can reduce the recommendation of that particular fertilizer, and we can also reduce the input cost, and also we can reduce the environmental impact in the atmosphere. So, based on the importance of that nutrient use efficiency, today I am going to deliver the topic nutrient use efficiency and integrated nutrient management. As I said, nutrient use efficiency is defined as yield per unit input. In agriculture, it is related to the only fertilizer only. So, nutrient use efficiency is often expressed as fresh weight or yield per content of the nutrient. Nutrient use efficiency is defined as the nutrient to which the nutrients and management practices interact to give a specified yield level. Improvement of the nutrient use efficiency is very much essential, and it is a prerequisite for expansion of the crop production in marginal lands with low nutrient availability. So nutrient use efficiency percentage formula is yield with applied nutrient minus yield without applied nutrient divided by the amount of nutrient applied into 100. Nutrient use efficiency, we can be defined it as a amount of dry matter produced for a unit of nutrient applied or absorbed. Nutrient use efficiency is equal to physiological efficiency and apparent recovery efficiency. So the classification of nutrient use efficiency is one is called agronomic efficiency and physiological efficiency, like that it is classified. For example, if you take agronomic efficiency, it is defined as the economic production obtained per unit of nutrient applied. It is calculated by the equation that is grain yield of fertilizer crop in kgs minus grain yield of unfertilized crop in kgs. That is called agronomic efficiency. In formula, if you see, it is defined as the economic production obtained, just now I told you, obtained for unit nutrient applied. It is calculated by the following equation, that is grain yield of fertilizer crop in kg minus grain yield of unfertilized crop in kg divided by quantity of the fertilizer applied in kgs. It gives the agronomic efficiency. Second one is the physiological efficiency. It is defined as the biological production obtained for unit of nutrient applied. It is calculated by the equation like that, total dry matter yield of fertilizer crop in kgs, total dry matter yield of unfertilized crop in kgs divided by nutrient uptake by fertilizer crop in kg minus nutrient uptake by the unfertilized crop in kg. Here we are taking into consideration nutrient uptake. Then third one is the apparent recovery efficiency. It is defined as the quantity of nutrient absorbed per unit of nutrient applied. It is calculated like that nutrient uptake by fertilizer crop minus nutrient uptake by unfertilized crop divided by quantity of fertilizer applied into 100. So this is the nutrient use efficiency of the different nutrients. Just in the introduction itself, I told it varies from nutrient to nutrient. So, for example, if you take nitrogen nutrient, the efficiency is 30 to 50%. The main causes for not available of the fully applied nutrient is that is due to the immobilization, volatilization, denitrification, leaching. All these losses occur due to this process. So only 30 to 50% of the nitrogen is efficiency. Applied fertilizer efficiency is 30 to 50% only. So like that, phosphorus fertilizers, if you take the efficiency, phosphorus nutrient efficiency is 15 to 20%. Mainly it is because of fixation in the soils like aluminum phosphate, iron phosphate and calcium phosphates. So most of the quantity it is fixed in the soils. So only 15 to 20% is available. So like that, potash fertilizers, if you take potash nutrient use efficiency, it is more when compared to the nitrogen and phosphorus. 70 to 80% of the nutrient efficiency is there with respect to the potash. The mainly that remaining 30% not availability is due to the fixation in the clay lattices. Sulfur, if you take that 8 to 10% only available, mainly due to the immobilization leaching with the water. Micronutrients, if you take zinc fertilizer, mainly that is very important fertilizer, zinc sulfate, only 1 to 2% of the nutrient use efficiencies we can get. So that is mainly due to the total quantities fixed in the soils. Factors. What are the factors affect the nutrient use efficiency? We take for one by one. Number one, we take with soil factors. Soil factors, there are different aspects, physical conditions, soil fertility, soil reaction, like that. Several factors are there. So physical conditions, plants grow on soil with poor physical condition will be poor due to the impeded drainage, restricted aeration, and unfavorable soil temperature, due to which the nutrients will not be used efficiently. So when there are the physical constants like the hard pan formation, like the poor drainage, and poor drainage means restricted aeration will be there, unfavorable soil temperature. All these soil physical conditions lead to the poor, due to the poor availability of the nutrient, that is poor use efficiency. Coarse textured soils are usually poorer in available nutrients than fine textured soils. On such soils, nitrogen and potash fertilizers should be more frequently applied. So that means depend upon the texture of the soil also. Coarse textured soils, the poor availability. Then coming to soil fertility, higher the soil fertility of the soil, the lower is the response. Higher the organic matter, more the nutrient use efficiency. That is a known fact. If the organic matter, if the organic carbon content is more, organic matter content is more, the whatever the apply nutrient, the use efficiency will be more. So if the already soil fertility is high, the response to the applied nutrients is low. So soil reaction, it is again the pH plays important role. Soil pH is the important aspect in selection of the right type of the phosphorus fertilizers, for example. Then coming to the climate factors, different parameters like temperature, rainfall, evaporation, length of day, and growing season. All these the climate factors, and rate of nitrification is slower in cooler climate than in warmer climate. Hence, more fertilizers are to be applied. So when the climate is cold, the rate of nitrification is really lower than when compared to the warmer climate, high temperatures. So hence the more fertilizers have to be applied. Higher amount of fertilizers are needed in high rainfall region due to leaching to get the expected yields. Because the heavy rainfall is there, the more amount of the fertilizers will be leached down to the down layers. So the requirement, the application of fertilizers required is more. In arid regions, soil moisture is a limiting factor to get the higher nutrient efficiency. For the better nutrient efficiency, the moisture plays important role. In arid regions where the rainfall is less, the water availability is less, there is a constant, there is a reduction in the nutrient use efficiency, then ultimately we have to apply the more fertilizers. The higher the light intensity, better the nutrient use efficiency. Then coming to third one, crop factors. Cation exchange capacity of the plant root influences the responsiveness of the crop. a large ramifying root system of the plant absorbs nutrients more efficiently, because the more efficient root system, where the more the, volume of the root system spread in the soil, that absorbs nutrients more efficiently. So the time of application of fertilizers should match the pattern of nutrient uptake to increase the nutrient use efficiency. For example, some crops require nutrients. The requirement varies from stage to stage. So, for example, rice, it requires more in as a tillering stage, and some fertilizers, for just like potash, it requires at panicle formation stage. So, the application of the nutrients should match the requirement of the nutrients by the crop. For legumes, nitrogen fertilizer may be reduced as they can fix atmospheric nitrogen to increase the nitrogen use efficiency. It is a known fact. Legumes, they will have nodules on the roots and stems. They will fix the atmospheric nitrogen. So there is they can fix atmosphere. So there is the requirement of nitrogen may be low. Then agronomic factors, if it comes, it includes selection of the fertilizer responsive crops and varieties, timely sowing, proper spacing, proper dose, time and method of fertilizer application to increase the yield and thereby increasing the nutrient use efficiency. So there are some crops, they will give very good response to the applied nutrients. Suppose, for example, maize, it is a loving nitrogen and zinc loving crop. When we apply those fertilizers, it is a responsive crop, we can tell. So depend upon that, these are the factors. And timely sowing, if we sow the crop timely, the response to the applied nutrient will be more. And the spacing also, proper dose, time, method, all these factors plays important role for the nutrient use efficiency. And then how to increase the nutrient use efficiency. Use efficiency of any nutrient can be increased by achieving potential yields of the crops by optimizing the different factors of the crop production. If you take one by one, number one, the selection of the suitable crops and varieties which are input responsive recommended by the region. So in that region, for example, particular crops varieties will be more responsive to the particular nutrients, like that. So we have to select the suitable crops to increase the applied nutrient use efficiency. Then sowing or planting the crops at optimum time. If the delayed timing is there, the more the fertilizer is required, the use efficiency of the nutrient will be lower. So sowing in time is very important. Maintaining optimum plant population and use of organic manures and biofertilizers to supplement the nutrients and also to bring ideal conditions for the crop growth. The inclusion of the legumes in cropping system is very important. If you include the legumes in the cropping system, the legumes will fix the atmospheric nitrogen into the soils and crops, so that we can reduce the application of the nitrogen fertilizers, and we can increase the nutrient use efficiency. The irrigation at critical growth stage to save the life, and with reference to the manuring and fertilizer application governs the use efficiency. Whenever the critical stage of the crop which requires more quantity of that particular nutrient, and whenever we apply the fertilizer followed by the little irrigation, it increases the use efficiency. So irrigation and water availability plays the important role. Deep primary tillage, though subsoiler or mold board plow, will encourage deeper penetration of the roots and extraction of more nutrients from the deeper layers and larger volume of the soil. Fertilizer scheduling must be based on the soil test values to prevent the nutrient deficiencies or luxury consumption. But depend upon the soil test value. If the soil test value is more, the less quantity of the fertilizer had to be applied. If the soil test value is high, the less number of the fertilizer have to be applied. If the soil test value is less, the more quantity of the fertilizers have to be applied. So depend upon the soil test value. Scheduling has to be done. Phosphorus and potash fertilizers and part of the nitrogen fertilizers should be applied at the basal and nitrogen in split doses. For light texture soils, potash also should be applied in the splits. So generally the phosphorus fertilizers is needed for the better root establishment at the initial stages. And phosphorus fertilizer also is some quantity of the potash fertilizer also required at the basal stage. So total phosphorus and potash, some 50 quantity of the potash fertilizer have to be applied at the basal, and some part of the nitrogen fertilizer can be applied at the basal. And nitrogen is required at different latter stages of the crop growth, so that nitrogen application has to be matched whenever the crop requires at the latter stages. So nitrogen in split doses have to be applied. For example, potash for light textured soils, the potash has to be applied in the splits. So band placement of the fertilizers are preferable to prevent the lashes. Then we apply the broadcasting and just covering the nutrient loss will be more. If you apply the soil in the place, if you place the soil and cover with the soil, if you place the soil at the below the soil zone, that is placement and covering the soil, it reduces the nutrient loss. Under moisture stress conditions, foliar application of urea at 2% concentration has to be done. So whenever the moisture is the constant, water is the constant, we should not take up the soil application. The only foliar spray is recommended. Micronutrient deficiencies should be corrected instantly. Zinc sulfate should be applied as a package once in 2 seasons. Problem soils must be ameliorated by taking reclamation measures. In problem soils, generally, the more nutrient deficiencies will get. First, the soils have to be reclaimed, the problems have to be rectified, then we can go for the fertilizer application. We can use the fertilizer, nutrient use efficiency in those soils. Agricultural operations like harrowing, earthing up, and weeding loosen the soil, conserve the moisture, and reduce the competition from weeds for nutrients and improve the nutrient use efficiency. Type of the soil and nature of the crop suggest the form of nutrients to apply for efficient use. In case of rain-fed and irrigated upland crops, not much difference in use efficiency, irrespective of whether nitrogen applied when nutrient applied in nitrate or whether the nitrogen applied in nitrate or ammonical or amide form. In case of submerged soil, rice crop is submerged. Nitrate, nitrogen containing fertilizers should be avoided to avoid the loss of nitrogen through denitrification. So the denitrification losses will be more in the flood conditions. So we have to avoid nitrate, nitrogen containing fertilizers. Calcium ammonium nitrate is preferred source of nitrogen for alkali soils. If choice is there, rock phosphate can be used in the acid soils. Conjunctive use of organic manures and chemical fertilizers in balanced form lead to the higher use efficiency of the nutrients. Organic manure should be incorporated into soil immediately after application through light plowing or harrowing to prevent the loss of the nitrogen. So biofertilizers like phosphorus solubilizing bacteria are to be used to improve the phosphorus use efficiency. Placement of fertilizer done 5 centimeters below the seed and 5 centimeters away from it by using the seed cum fertilizer drill will increase the nutrient use efficiency. In submitted rights, broadcasting is adequate for sugarcane and cotton. Packet method at 10 to 15 centimeter depth and 7 to 10 centimeter away is better. In case of trees, basin application of 10 to 15 centimeters below the soil surface, leaving 30 centimeters all around the trunk basin is recommended. Swift application of nitrogen fertilizers to prevent the losses due to the leaching. The use of low release nitrogen fertilizer like urea, formaldehyde, sulfur coated urea, neem coated urea, etc. has to be applied to increase the nutrient use efficiency. Use of nitrification inhibitor, like just like for example nitrogen sorrow, to retard the conversion of the ammonical nitrogen to nitrate nitrogen to prevent leaching and to make available to the crops for quite longer period. By the integration of the inorganic nitrogen with organic sources, the soil physical condition can be optimized besides adding the nutrients to the soil. And then coming to the phosphorus and potash use efficiency, phosphorus use efficiency can be increased by decreasing the phosphorus fixation and balanced application of the nutrients. Phosphorus fixation can be reduced by the judicious application of the organic manures. Application of phosphorus fertilizer by placement, inoculation, either seed or soil with phosphorus solubilizing bacteria like Pseudomonas, Bacillus megatherium, Phosphaticum. Like that, if you use the phosphorus solubilizing bacteria, the phosphorus use efficiency can be increased. Then coming to potash use efficiency, it also can be enhanced by preventing leaching loss by split application in the light soils. Application of organic manures and balanced application of the nutrients is important in the K use, increasing the K use efficiency. Similarly, for sulfur use efficiency, sulfur in soil solution is present as sulfate ions and more prone to the leaching losses. So the losses can be prevented by applying organic manures to improve water holding capacity of the soil, and it also acts as a source of sulfur. Sulfur oxidation can be facilitated by providing the oxidizer conditions in the soil. So zinc use efficiency can also be increased by when the the zinc fertilizer should not be applied with phosphatic fertilizers. So it should be applied separately, not along with the phosphorus fertilizers. Then it will be fixed as a zinc phosphate. So maintaining the soil pH between 5.5 to 6.5 by applying the organic manures is important factor to increase the zinc use efficiency. Then iron is efficiency. Most available form of iron is in ferric form. All the measures which govern the soil reaction will influence the iron availability. Iron availability is more in acidic soils. Application of organic manures, including green manure crops, improve the use efficiency of iron, and that is due to the acidifying the rhizosphere due to the release of the organic acids, supplementing with the iron after decomposition. It acts as a substrate for heterotrophic bacteria that can reduce ferric to ferrous. The microbes also produce chelating ligands called heterospores that can form complex with Fe3 ions, which can be absorbed into the plant. Reclamation of the alkali soils, and if deficiency appears on the standing crop, take foliar application of the iron. Then integrated nutrient management, it is plays important role. What is the integrated nutrient management? It is actually the technical and managerial component achieving the objective of the integrated plant nutrient system under the farm situations. It also take into consideration of all the factors of the soil crop management, including management of all other inputs such as water, agrochemicals, amendments, and etc. besides the nutrients. So integrated nutrient management is the integrated use of organic manures and chemical fertilizers has been found promising in arresting the decline in productivity through increased fertilizer use efficiency and correcting the marginal deficiencies of the secondary and micronutrients and their beneficial influences on the physical and biological properties of the soil. In literature, there are three technologies are used to convey the same meaning. That is integrated plant nutrient system, that is IPNS, integrated plant nutrient supply systems, that is IPNS systems, and integrated nutrient management, that is INM. Although these terminologies may look the same, yet they convey the somewhat different conditions, different mean. The integrated plant nutrient system means it is used to maintain or adjust soil fertility or plant nutrient supply to achieve a given level of the crop production. This is done by optimizing the benefits from all possible sources of the plant nutrients. The basic concept of the INM or IPNM is the adjustment of the plant nutrient supply to an optimum level for sustaining the desired crop productivity. The integrated plant nutrient system means the supply of nutrients to the plants from various sources of the nutrients. That is, nutrient reserves already available in the soil and from organic sources like farmyard manure, compost, green manure, crop residues, and other organic fertilizers and fertilizers. So the definition of the IPNS is this is the concept which aims at the maintenance or adjustment of the soil fertility and the plant nutrient supply to an optimum level for sustaining the desired crop productivity through optimization of benefit from all possible sources of the plant nutrients in an integrated manner. So this is the definition given by the Roy during 1991. What are the goals of the integrated nutrient management? Its main goals are to maintain the soil productivity, to ensure the productive and sustainable agriculture, to reduce the expenditure on the cost of the purchased inputs by using farmyard manure and crop residues, etc., to utilize the potential benefits of the green manures, leguminous crops, and biofertilizers, to prevent the degradation of the environment, to meet the social and economic aspiration of the farmers without harming the natural resource base of the agricultural production. What are the components? The integration of the soil fertility, restoring crops like green manures and legumes, and recycling of the crop residues, use of organic manures like farmyard manure, compost, vermicompost, biogas slurry, poultry manure, biocompost, press mud, cakes, phosphocompost, etc., and utilization of the biofertilizers, efficient genotypes, balanced use of fertilizer nutrients as per requirement, and targeted yields. So the INM technologies must be compatible with the local farming system if they are to find acceptance and adoption. Common constraints in the integrated nutrient management are the non-availability of the sufficient farmyard manures. The organic manures may not be available in sufficient quantities to meet the actual requirement of the nutrients, and difficulties in growing green manure crops, non-availability of the biofertilizers, and non-availability of the sufficient soil testing facilities, high cost of the chemical fertilizers, scarcity for availability of the water, lack of knowledge and poor advisory services, non-availability of the sufficient improved seeds. These are the constants in the INM. What is the crop residue management? The residue burning has been a serious problem in India. Mainly in the Punjab and Haryana states, it is a main problem which is causing more concern in the environment in the surrounding areas like Delhi and etc. states. So this apart from contributing to harmful greenhouse gas emission, deprives the soil of several benefits associated with the recycling of the crop residues. About 30% of the nitrogen, 60 to 70% of the phosphorus, and 75% of the potash contained in crop residues is available to the first crop and rest to the subsequent crops. So the crop residues, apart from acting as a mulch, it adds soil organic matter content, it enhances the nutrient use efficiency, and improves the soil physical properties and microbial activity. Thank you very much for patience listening. Thank you.